we are going to answer it in a third way, okay, which is the quickest one, okay? So as you have seen, first, second way, it has like, we tried our best to have a look at our expression and understand it, right? Okay, so we are going to try to focus more on 1 over x, what is it? We are going to use the number line to answer the question, straightforward. So what I have, I know that 1 over x is a number such that 1 over x is between 1 and 10. Okay? Very important, I'm going to draw the number line not for x, it's the number line for 1 over x. Do not mix the two. Okay, what I can do, not to mix the two, I can call all this y. So let y equal 1 over x. Okay? It's clear. Let y equal 1 over x. Then, what I have here, I have negative 1 over 2, less than 1 over x, less than 10. This comes to say that y is more than negative half, less than 10. Okay. Now, when I put y equal to 1 over x, y is calculable, is defined only when x is different of 0, right? Y is calculable when x is different of 0. Okay, so I have y equal 1 over x and x is different of 0. What are the possible values for y? Okay, if I have my y is different of 0, x is different of 0, then 1 over x is also different of 0. This is the key point. Okay, clear? So now the number line, if I want to represent y on the number line, I'm talking about y, this is, I want to find y is between negative half and 10. Okay, this is y. And its values between negative half and 10. 10 and half, negative half, sorry, are not included, are not one of the possible values of y. Okay? So, y is calculable when x is different of 0. I have for any x different of 0, 1 over x is also different of 0. Okay. For any x different of 0, 1 over x is also different of 0. Okay? Then it means that my y cannot be equal to 0 in any way, because I have this condition, x cannot be equal to 0. Okay? Then my y cannot be equal to 0. Okay? Clear? So my problem is, this is for x. What are the values of x for which this is true? The value 0 here is not one of them. Right? Because if x equal to 0, this is not possible. Okay, so I'm excluding this. I'm doing here. Y is calculable when x is equal to 0. Now for any x belonging to half, for any of these possibilities here, 1 over x is never equal to, like I'm going backwards, forward backwards. Okay, I'm doing some analysis. Okay? Then y cannot be equal to 0. Okay, since this is the line for y, this is the line for x, number line for y and x. Okay? So since x cannot be equal to 0, I'm deducing that y cannot be equal to 0. Now I'm going back to the number line of y, and I'm taking out 0 as one of the possibilities of y. Okay? Clear? Then, what I'm having here actually, if I combine this information and this one, okay, I would call this information, okay, this inequality, thus y is more than negative half, less than 10, and y is different of 0. Right? Y satisfies this and also this. How did I get this? By doing some gradients. Okay, clear, and applying some properties. It's something obvious. If x is different of 0, the inverse of it. Everyone knows the inverse function, right? Not the reciprocal, the inverse, 1 over x, right? 1 over x never equal to 0, right? Just, okay? Here, okay. Since now I'm adding this condition here, I'm reducing it. It's not in the question, it's me doing some job to find it. Read it, understanding what I have. Okay, I know my inverse function, the properties of it, let's say. I know for any x different of 0, my inverse function never equal to 0, right? Okay? Then my problem here, this one, y is between negative half and 2. If I take the 0 from, then I can say that y belongs to negative half 0, open, or not end, or y is between 0 and 10. Okay, because 0 is not a possible value of y, but I'm left, if I do the intersection between these two, I'm going to get this set. Okay? Here. Okay? So now what I have, just to say that 1 over x is between negative half and 10, comes to say that 1 over x, y, okay, is more than negative half, less than 0, or my y is more than 0 and less than 10. Okay? Here, this is me understanding what I have. Okay? Again, we're going to mix these two lines. The line for the y and the line for 1 over x, the number line for 1 over x, and the number line for x. Okay? Clear? Now, I have these two problems. So it turns out that to solve this problem, I'm having these two. Okay? So, I'm just putting here that x is equal to 0. To 1 over x can be equal to 0. For this is to be true, x cannot be equal to 0, right?
Yes.
Okay? Now, do I have any property to apply here? The answer is yes. I have these properties. Now, before I have no properties. I cannot use this one I'm going to talk about. When we have done 2 ways, it was impossible to do what we are going to do now. We have these 2 properties. We have if A, B, both of them are strictly positive, and A is less than B, then 1 over A is less than 1 over B. Both my quantities are bigger than 0. This is one of the properties. The second one is this one. If both of them are negative, and let's say A is less than B, or A bigger than B, never mind, depends, okay? Then I'm having 1 over A is bigger than 1 over B. I have these 2 properties. The problem with the previous question, I didn't have this information. Previously, we had something like this, 1 over x bigger than negative half, and 1 over x less than 10. And x is in R. In this case, this quantity here, it can be either positive or negative, right? So if it is positive, abnormal in this case. Both sides positive, both sides negative at the same time. Strictly positive, strictly negative at the same time. Right? That I can't use this property. Okay? Is it clear? I can't use it. I don't have this information. This one. This one is missing here for the previous cases. In these cases, this information, I don't have it. That's why it wasn't possible to do this job. Okay? Now, since I have this information, A less than B, A, or B less than A, never mind, B less than A, and both of them are, okay, B bigger than A, and both of them are negative, right, in this case. I'm satisfying the if, right? Then I have a right to inverse and the quantities and the inverse the order. Okay? I erase the boxes. Okay, never mind, I'll just pass it. So for first one, I inverse. The inverse of negative half is negative 2. The inverse of x is x, because x is equal to 0, right? And here I inverse the order. Or I inverse here 1 over x is x. I inverse here 10 is 1 over 10. The order I inverse. Okay? Then here I have an x equal to 0. By condition, I'll just give it for now. Then you will please try to keep it all the time. You will see that you get it of it. Then this one comes to say x belongs to negative infinity. 2 union 1 over 10 plus infinity. 0 is not here, right? Okay? Then I have the same answer. Okay? Again, I can't use these properties for the previous cases because I have 1 over x is bigger than negative half, and x is in R. Now for this here, for this to be true, if this is true, then x is somehow negative. Right? X is negative number for this to be true. For this to be true, x is a positive number. Okay, I'm not discussing the sign of it right now. But if I want to have a saying about the sign of it, I can multiply by x and say follow, like we did before. Multiply by x here, like we did before, right? Multiply everything by x. Why? Because x is negative. 1 over x, you have to understand it. 1 over x is less than 0, then x itself is less than 0. It's understood. Okay. Then I can multiply by x everywhere and inverse the order. 1 over x is less than 10 more than 0, then x is more than 0. Because for this to be more than 0, x has to be more than 0. I can multiply by x and inverse the order also. Okay? Like we did with the previous questions. Okay, here not to check what is the sign of it and so on, talking about it. I use this property straightforward. Okay, I use my property straightforward. Okay, not to make it longer. Is it clear? The most important is that I have this. Otherwise, I can't do anything. I don't have to write them. I have to prove that I have these cases. Okay, I have to show why I do have these cases. Okay? Clear? Then this is the third way and the quickest way how to answer this question. Okay? Now, y is between negative half and 10. Then the set of solutions, the possible values of my x are between negative infinity to negative 2, right? Don't take negative 2. And from 1 over 10 to plus infinity. So 1 over x is in here. X satisfying those conditions actually is somewhere here. Okay? So please do not mix the number line for 1 over x or y if you want.